Well, hi, and thanks for joining me here in my shop looking at this radio, which I kind of thought I wouldn't be looking underneath here too much anymore, but it doesn't seem to be the case. So, last thing I was looking at was this filter capacitor, and a precursory look suggests it's been partially paralleled with this one, and I was able to loosen it up, just cut this off in the last video, swing it out, and wow, there's more stories to be told on this radio. Now that things are kind of opened up a bit, you can see a little better into it. So I think I'll take a closer look here. So I think the things of interest are, there's a new capacitor there. There's a new one here, just out of your view. There's a high wattage resistor here. So there's quite a few parts that have been replaced. I mean, there's this curious arrangement with the two resistors hooked up in series, which would not be a normal thing to do in a factory setting. So there's quite a bit's been done in here. Lots of another replaced capacitor over here. There's an orange drop right there. Lots and lots. Funny though, there's still original paper ones sitting in here. You'd think someone went so far as to replace this many capacitors, they would have just knocked out the last couple paper ones. And this thing too. The real issue here of the video, what to do about this. You know, it looks like one segment of it has been became too weak, and so this was put in. You know, but this is 4040. You can see it right there. Well, a little bit of focusing you could. There we go. 4040. So you kind of think if, well, one side's failed, the other side's probably not long for this world either. But there it is, still connected to the radio. And there's been a fair number of things done up in here. Like this resistor, I'm sure it's not original. This guy up here. Of course, that's not original. This may not be original either. I'm not sure about that. Here's this diode sitting here. It's just hard for you to see it on camera there, but there's a diode sitting here. What the heck is that doing there? I don't know. So stuff has happened to this radio, and I'm just seeing there's a binding post down here. It's got solder all over it, but no wires on it. So something was there at one time. So what are we going to do about this guy here? Let's see, where's this negative lead go? Negative lead goes to a grounded terminal right there. That terminal actually goes right down to the chassis. This is connected to it here, so this is all ground point. Now, what about the negative of this one? That's this lead here. You would kind of guess, at least I would kind of guess. Oh, for sure. The negative is going into this terminal, and this terminal is screwed right to the this terminal here is screwed right to the chassis. So it's just grounded the very same as this, the negative terminal. So the positive of this goes here. The positive of the yellow positive, goes here. This is 100. This is 40. This is 40, probably running like a 10 or a 5. I'm guessing. That's why this was done. So why didn't he cut this wire away and get rid of it? Because although it may not hurt that much, eventually this could develop a short circuit or something. Why leave it in there? I don't know. Because he did fairly extensive work here. So he's got 100 on this side, and on this side is the original 40. Probably not 40 anymore. Now which side is which? One you could call the input side, and one you can call the output side. And so I'm thinking, you know, here's the rectifier tube right here. And if we look at the other view, you can see the tube right here, a rectifier tube. And I think this is the cathode, but I'm going to take a look in a moment. Figure out where this resistor is connected, and what is it? It's a 27, that's a brown? 270 ohm. It's very likely a cathode resistor. If so, it would have normally have a fairly large capacitor across it. I'm not sure. Well, let's take a look at the pinout for this. Is that 35Z5? Is that what it was? Thirty-five Z5 half wave rectifier. Now, is that for sure what that is? Pretty sure, but let's be absolutely sure at this point. Can't read it. Twenty-five Z5. Okay, 25 Z5, 35 Z5, probably pretty much exactly the same thing. Let's see, except for the heater. 25. We'll go with vacuum rectifier doubler. Vacuum rectifier doubler. What's that? Glass tube uses half wave rectifier or voltage doubler in AC/DC receivers. For voltage doubler considerations, refer to application section outline blah 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 blah. Tube requires 6 contact socket and mount to any position blah blah. Heater volts 25. So it's just a half wave rectifier. I don't quite follow that. Half wave rectifier. Because when I look in here, I see two. I'm just showing it to the wrong camera there. Okay, so there's a 25Z5. There it is. And I see 2 plates, 2 cathodes. So isn't that a full wave? Ah, I don't know. My head is spinning here. I'm thinking, what? It must be quick. Give me more coffee. No, coffee's over for the day. Oh, well, anyway, we won't worry about it. Half wave rectifier. So that means the half wave rectifier produces a pretty hummy output, and it really needs to be filtered quite strongly, depending upon, of course, many other factors. But so 1500 ohm. Oh yeah, right. So I put this. Yeah. Okay. Back to the book. That's no different than running downstairs into a room and then getting there and going, well, what am I doing here? Okay, here we are. So we want to look at, here's the two heaters right there. Right there. And the next pin over is this one. Let's pin over. Next pin over is a plate. Is that right? Ah. Either direction, the next pin is a plate, and the last pin, if I can put it that way, is the cathode. So, what's going on here then? Well, I'm all turned around. Yeah, see, so this is showing the two components, the two tubes. They're just put in parallel and used like 1, 2. Maybe there's some advantage to this, some heat dissipation or something, so it really is always used as a half wave. You could do full wave with it though. So it's supposed to go from there through the field coil that no longer exists. A choke coil. I haven't seen a choke coil on this radio. I think I've been here already earlier on when we were looking at it. I think I noticed that. I kind of wondered, what the heck? There's absolutely no choke coil. I don't even see where you could put one. Because they're a fair size. You know, they're similar in size to this. They're bigger than this, typically. It's kind of mysterious stuff here. So it looks like this power supply has really been recreated, kind of on a different basis. That maybe once the field coil went, then following this design here, basically this filtering here, is a no-no. It's just not gonna work the way it might be desired. I mean, obviously the sizes of these things have to be, pushed up quite a bit. The size of these capacitors, if you're not going to use a choke coil. And there's a good chance that this binding post has been installed also as an addition. I can't be sure about that, but it does look just a little odd when you look at the back of the radio. There's a screw for it. I don't know what to think of that. The other ones are riveted. You can see the rivet. Well, you could see the rivet. Well, I'd like to show you the rivet. Oh my gosh, come on, camera. I don't know. Maybe all the bright objects are throwing it off or something. But anyway, trust me, those things are riveted in, not screwed in. Screwed in that's what comes along later. So maybe this whole thing has been added in, a place to put this resistor. I mean, it's a sensible thing to do. So all these wires that are connected to it have come from somewhere else. Like this post down here that's no longer being used. And I don't know what else to say about that. I think what would be real sensible then, easy, would be to get rid of this. Goodbye. Get rid of this. Put two new 40s, 50s. I have 50s. 50s here. Even though this is 100. Try 50s anyway. give it a try. What this diode's doing here, I'm still really stuck. Why is there a resistor in the plate circuit? Usually in the cathode. Here, let's do something here. Just because I'm always a little unsure of everything I'm doing and saying, I like to double check and verify stuff. This pin is connected dire. Oh, that's going to be the heater. That's just the heater. Never mind. Yeah, just ignore me here. So the next one up here, I can't. Looks like it's grounded. So it looks like the where is ground? Ground is here. So I'm never too sure what to think about these symbols, because there are all kinds of chassis grounds in this radio. We've seen them, all those rivets and connections. The chassis is in this radio is a component of the whole thing. So what does that mean? And there's another ground over here. Now that one's a little more obvious because it's on the antenna, and the antenna is not actually directly connected to the radio. So it kind of has its own thing going on into the earth. So here's another thing. You just notice that now, that little arrow there. There's another little arrow there. Well, I guess that represents the power cord. Yeah, that must be what that is. Yeah, it says 110. 110. So there you are. So that's just the power cord. I just hadn't noticed that before. Usually they put those two very close together and make it look like an outlet. Like a plug, rather. So what has happened to all of this? Well, assuming this one once existed, the choke here, it's gone. And the field coil, it's gone. So we know what happened to those two things. If you just took those out of the circuit, what would you have? You'd have a 20. Oh, this is really hard. I just have so much trouble trying to picture these things. You'd have a 20 up to here, and then beyond that, it looks like a 4. Well, see, it doesn't make sense, because you have to have this connected around it. Then it makes sense. This is kind of the ground line right here. These two capacitors are connected from high voltage to ground, and this one, high voltage to ground. It's getting its high voltage through the inductor here. I hope I'm getting this on screen okay. I know it's a little blurry. So what do? They turn this whole thing into something quite different. That's sitting where the inductor should be. That's quite typical. So you have it come out of the supply. First capacitor, then a resistor, then the next capacitor. And then the fully filtered supply is fed, well, throughout the radio in this case. So a lot of other radios, they use the fully filtered supply to go up into the front end of the radio, where a little bit of hum is going to make a big difference. And they use the semi-filtered component or supply to feed the output, where a touch of hum, as long as it's below a certain amount, it's imperceptible. But there can be more there. They haven't done that here. Here they just have... Yeah, if you drew this a little bit differently, it would look like your typical capacitor thing. Just the way they've kind of drawn it here. It's just... I guess he'd like to have his inductors vertical or something. I don't know. So there you go. So, but I don't see 40 here. I don't see 40 yet. There was a 40 here. So, you know, it could be that this radio's been through a series of changes from maybe one repair person to the next, or even one repair event for the same guy doing it. I thought I spotted a cold solder joint there, but no. So the reason I'm so hesitant to just get in there and start whittling away is that until I really understand what's going on, I stand a really good chance of doing something stupid. Or maybe dumb would be a better word for it there. And I've faced this a couple of times now. I've got a couple of videos of me facing radios that people have altered substantially. And it's no party. It's no party, I'm telling you. It's no party at all. That may be the one thing worse than having a radio with no schematic, is having a radio with a schematic, but the radio's been altered substantially. Yeah. Well, I still think the plan to change this to 50 and a 50 and get rid of all this stuff is good. It's going to reveal more of the radio. It's going to make more of the radio visible afterwards. If we run the radio and the hum has come, we can up this size here, even all the way back up to 100. And then we're pretty much just exactly what is here now, just with better parts. That's the only difference. That'll give me a clearer view down here, this resistor and other stuff, to sort out more of what's going on. So I think that's a smart move. So I think I'll do that. Let's do that. Another smart move would be turn on the soldering iron. So I think I gotta get some parts and let my soldering iron warm up. So I'll just stop here for a moment, which you may not even perceive.